Sorry, let's go back here. A1 notes. I'm going to go through these again real quick. So I forgot to record. Now that we're on the video. So the equation 2 expressed has the same value joined with an equal sign. Examples: 2x plus 3 equals 10, and y equals x minus 5. The equal sign makes it an equation. A variable's letter represents an unknown number, so something we don't know. Constant is a number not with a variable. Okay, it's just a number by itself, which we already knew that. And numerical coefficient is a number in front of the variable. So when we're solving these, and don't be freaked out by fractions, okay, we still want to just kind of think about it in terms of what is the thing I'm solving for? I want to know what the unknown value is. So the unknown value is x. Everybody's uncomfortable saying that? No? Okay. How about now? Maybe? Did you said no? Oh, okay. Well, if you don't know, then that's fine. It's not a big deal. But we don't know what x is, and that's the goal. So whenever you get an equation that says solve, you're solving for the unknown value, which is x. Okay? So 2 is my problem, not the 3/4. I know when you look at this, you're going to see the 3/4 and freak out because it's a fraction. However, that is not next to our variable, so we don't care about it yet. The only thing that we care about is getting this 2 off with division. And why am I using division? Because it's the opposite of what's there, which is multiplication. A number next to a variable, so anytime, this is a good point, 6x means 6 times x. People forget that. They think there's no sign, they're not sure what it is. It's multiplication. Okay? So we're going to divide 2 to both sides. Now this is where it gets weird, because it's a fraction. I'm going to write it on the side. Normally you can just divide right underneath it, but I'm going to write it right here so we can do some fraction work. So dividing 2 to both sides. That's the golden rule. In algebra, okay, it's up there in that poster, in the middle one there. In algebra, you can do anything at any time to any equation as long as you do it to both sides. So if I want to add 3, I can do that. If I want to minus 4, I can do that at any time. Obviously, we have to have a purpose. Okay, we have to have a direction we're going, and our direction here is solving for x. So here we go. This cancels. That's why we divided it. When you divide by a number, we do what? By fractions, we do good. Times by the reciprocal, or flip and multiply. 3 times 1 is 3. 4 times 2 is 8. Our answer is 3/8. That is our answer. Okay, so you can check your solution, okay, by taking your answer and putting it in for x. You can check your solution by putting it in for x. So I'm going to do that really quickly. So this is the check. 2 times 3/8 equals 3/4. What is 2 times 3/8? Nope, not 6/16. 6 over, because it's a 1, right? 6/8. 6/8 reduces to 3/4. Our answer is correct. That's how you check. Okay. So we got the show you know here, same deal. 3x, I don't like they write on the side, but you can write it right here if you want. But you can put it there if that's 3. Divide by 3. X equals, we flip and multiply. -2/9. I flip the 3 to 1/3 and multiply because it's division of a fraction. -2 times 1 is -2. 3 times 3 is 9. Okay, left side. We're checking it, so we plug that answer back in. I'll move here in a second, sorry. 3 times -2/9 equals -2/3. So you put the -2/9 in for x. 3 times -2/9 is -6/9. -6/9 reduces to -2/3. Everybody good? All right, so this one here. M over 3 equals negative 2/5. How do we get rid of the 3? This is the most often mistake. Besides you two. Connor, yeah, multiply the 3. M over 3 means M divided by 3. So we have to get rid of the 3 as multiplication. So I like to slide a 3 there and slide a 3 there. That makes that cancel. Multiply. Negative 6/5. Why does it just 3 go to the top? Because it's over 1. A lot of people, and I think Noel might have kind of said this a little bit earlier, you don't times 3 top and bottom because, again, if you multiply 3 to top and bottom, what is 3 over 3? 1. You just changed it. Yeah, so like you exactly. So if you times if you times the whole number to top and bottom, you're timesing that fraction by 1. Not by that number, so nothing changes. Yeah, exactly. People get confused with that. So negative 6/5, let's go and stay in the habit of checking this here. So it would be negative 6 over 5 divided by 3. That's how you'd write it. And you're saying, whoa, that's fraction. Well, that's fine. Let's just write it like this then. That's the same thing, correct? We're going to flip and multiply. Okay, we get negative 6 over 15, which reduces to negative 3 over 5. Or 2 over 5, excuse me. And we know it's correct. We just verified. Okay, we'll just do one more page here. Got it? Attaboy. All right. So this one we're doing some more division. Okay, so with the division I have to multiply both sides by 2. I get x, that's gone, equals 10 over 6, which x equals 5 over 3 when it's fully reduced. So again, if I went too fast, it has it set up for me. It tells me I need to multiply by a number, which that number is 2. Did it to both sides, and then reduce the fraction. Now we're going to check. I'm going to write it sideways to start. 5/3 over 2, or 5/3 divided by 2. So 5/3 times 1 over 2. Because remember, it's over 1. 5 over 6. That's what I had. So we just confirmed it. Okay, questions, concerns? Again, don't let the fractions psych you out. The actual steps are easy. Fractions you can handle. We good? Okay, so let's get this one here. Last one, and then we'll call it a day. Okay, so this one, what's wrong with this one? Yeah, they're written in mixed numbers, and we want to make those improper fractions. So, do you guys know how to do that? You go 2 times 2 plus 1, right? So you times the mixed number, like the whole number, by the denominator, and add it to the top. So 2 times 2 is 4, plus 1 is 5. You keep the negative. So the good point here, you keep the negative, you don't like re-multiply it. You know your fraction's negative because this number's negative. So we're like this. And then I'll change this one. 3 times 2 is 6, plus 1 is 7. Okay, if I'm losing anybody, I'll do this one out for you. You take the whole number, you times it by 2. It's 6, and then you add it to what you have. You'll see that negative 3.5 and negative 7.5 is the same number. They're both 3.5 from your calculator. So you can check that to make sure you did it right. Your calculator's making sure that that's negative 2.5. Oh, that's negative 2.5. I'm good. Okay, so this one, we divide the whole fraction off. And the negative of it. Why do I divide the negative off? Well, one, because it's there. But also, if I don't, I'd have a negative k. We're solving for what kind of k? Yeah, we want to know what positive k is. We want to know what opposite k is. It's written kind of bad there. Divide by negative 5/2. That makes that cancel. We'll flip and multiply here. And you'll see, if you do your, remember we talked about that, those will cancel. You can go and multiply and simplify if you want, but your answer is going to be a negative 7 over negative 5, which is 7/5. So 7/5 would be our answer there. Questions? Twos. Because 2 over 2 is 1, so they do cancel. But Brett, you definitely can multiply if you'd like. You can go 14, and you can go negative 10. That reduces to 7 over 5 still, so you'll still get the same answer. Okay. Okay, so if I want to check that, I will tell you this. It's best to check this answer by putting it in. Ooh, red on red's a little too much. That's all right for this time. Put it into here. Don't put it into there because we'll make those improper again. Okay, so put it into the spot where you made them improper fractions when you're checking. So when I check this, I'm going to go negative 5/2 times 7 over 5 equals negative 7 over 2. So again, you can kind of see this. The 5's cancel here. So we're verified. You can multiply them. Again, like I just told Brett, you can multiply them. Be negative 35 over 10, and you reduce that again to negative 7 over 2. Okay? All right, we'll stop there for today. So again, work on that nutrition math link, the first piece, please.